Hi guys, today I want to talk a little bit about changing fractions into decimals and specifically in instances where our denominator is not a number that's easy to change into a 10, 100, or 1,000. Now before we do that, I want to explain something a little bit. So let's assume that this orange piece here is equivalent to one whole. Now we know that if we take this gray or silver block, we know we can call this piece 1/10 of our whole. Now, the reason being because we know that it takes 10 of these pieces to make a whole orange block. So this is 1 out of 10. Now, remember, our denominator tells us how many pieces that we're splitting something into. So we're basically splitting this whole into 10 pieces. Now, if we were to change this particular fraction into a decimal, we know that it would be 0 and 1/10, the exact same way that we say it because we have that 10 in the denominator. One other way we can look at this, though, is that when we're looking at a fraction, we're thinking of dividing something up. So we're basically dividing this whole orange piece into 10 equivalent parts. So one way we can look at this is we can look at this fraction bar as a division symbol because that's what it is doing. That's what it is. So one way we can look at it is 1 divided by 10. Now remember, whatever number is on top in our numerator is the number that we're dividing up, and whatever number is in our denominator, that is how many pieces we are dividing it into. So what I'm going to do is I'm going to say 1 divided by 10. If I add a decimal and a 0 here, it's still equivalent to 1. And then I'm just going to divide like normal. So I'm going to say how many groups of 10 and 1? None. How many groups of 10 and 10? 1. 1 times 10 is 10. And I get a 0. And notice we have the same thing. Now, we do this because we can use this in situations where our denominator is not easy to change into a tenth, a hundredth, or a thousandth. And let me give you a couple examples of what that might look like. One example of that would be 1/6. 1/6. Now, 1/6 would be an example of a time where we're splitting something up into 6 equivalent pieces. If we want to see what that would look like, it would look kind of like this. So it would be like a green piece, and this gray piece here would be equivalent to 1/6 because it would take 6 of these pieces to make one whole green piece. Now, because this denominator here, 6, is not easy to change into a 10, 100, or 1,000, there's no whole number that we can multiply 6 by to get to a 10, 100, 1,000, even further, 10,000, 100,000, millionth. So what we're going to do is we are going to use this here, and we are going to divide. We know we're taking 1 and dividing it up into 6 parts, and we're only taking one of those parts. So I'm going to say 1 divided by 6. I'm going to put down a decimal and a 0 here. And I'm going to divide just like normal again. I always know if it's a fraction that's not an improper fraction, it's always going to start with a 0 or a 0 and a decimal point. I'm going to say how many 6s can I make from 10? It's going to be 1. 1 times 6 is 6. 10 minus 6 is 4. Now, what I'm going to do when I get a remainder here is I'm just going to add another 0. Because it's still equivalent to 1. I'm not changing anything. I'm going to bring it down. Now, I need to know how many groups of 6 and 40. That's going to be 6. 6 times 6 is 36. And you're going to notice something happens here. I'm going to get 40 minus 36 is 4. If I bring down another 0, notice the same thing is going to happen. So what's going to happen here is we're just going to get repeated 6s like this. That's just going to continue happening. 0.1666666. Now, this is going to happen a lot when we're looking at fractions. And when we divide fractions, we always want to stop at one of 2 points. Number one, when the fraction terminates or the decimal terminates. This would be an example. We got 1/10 and then it stopped. We got a 0 down here as a remainder. The other time that we know we can stop is when we get what we call a repeat. Now, here's how we handle a repeat. I'm going to write this decimal as 0 and 0.166 or 166 thousandths. But what I'm going to do is I'm going to put this little line, this little bar over just the sixes. And that tells me when I write this decimal that the sixes are going to repeat. So I know that that is a repeated part of the decimal. Now, we could do this with all sorts of different decimals. We could do it with 1/3. We could do it with we already did 1/6. We could try 1/9, and you could even do it if the numerator is something different. So example 2/3. Try to see if you can make this work for some of these fractions: 1/3, 1/9, and 2/3, and see if you are able to divide a fraction out to find its decimal equivalent. Remember also that this will also work for any fraction that we've talked about so far. So fourths and fifths and halves. You can use it for any of those as well. So good luck in changing some of these fractions into decimals.